Hello, good morning. Under that trigonometric function, we look at the definition of an angle. We said that an angle is formed where two lines meets, and angles are generally measured in either degree or radian. You have ways of converting from degree to radian and vice versa. You can see from the slide that I have displayed in equation 5 and 6. Equation 5 is used to convert from degree to radian, while equation 6 is used to convert from radian to degree. 1 degree is equals to pi all over 180 radian. 1 radian is equals to 180 degree divided by pi. So those are the two simple ways we convert an angle from degree and from degree to radian and from radian to degree. In the first example we looked at last week, we'll look at how to convert angles from degree to radian. In example 1, we are asked to convert 30 degrees, 120 degrees, 270 degrees, 315 degrees to radian. And as I have said, 1 degree is equals to pi all over 180 degrees. So if you are asked to convert 30 degrees to radian, it means it's going to be pi divided by 180 times 30. 30 divided by 30 will give us 1. 180 divided by 30 will give us 6. So it means that 30 degrees is equivalent to pi all over 6 radian. That is one of the questions we look at last week. We'll look at example 2. We are asked to convert from radians to degree. This is just a recap of what we did last week. Express the following angles in degrees. 3 pi all over 4 radian, pi all over 12 radian, 3 pi all over 2 radian, 5 pi all over 4 radian. Now for the first one, we all know from the simple formula that I have explained to you that 1 radian is equals to 180 divided by pi. So if you are now asked to convert 3 pi all over 80 divided by pi, pi will cancel out pi. If you multiply 3 by 180 and divide it by 4, it will give you 135 degrees, which means that 3 pi all over 4 radian is equals to 135 degrees. The same procedure you use in solving the Roman figure 2, Roman figure 3, and Roman figure 4. Now we come to trigonometrical ratio. Under trigonometrical ratio, we'll be looking at trigonometrical functions. We'll look at the SOHCAHTOA, that is sine equals to opposite all over hypotenuse. Cosine is adjacent all over hypotenuse. Tan is equals to opposite all over adjacent. After that, we'll look at Pythagoras theorem. Now, before diving into this, we want to look at the trig ratio of special angles. As I said last week, for those of us that attended the class, an angle of multiple of 15, including 0, is called a special angle, which means that angle like 0 degrees, 15 degrees, 30 degrees, 45 degrees, and so on and so forth are special angles. Why do we call them special angle? They are called special angles because we have a peculiar and a specific way of deriving their values. Now for like 30 degrees and 60 degrees, we use the triangle in the right hand side. This triangle is what we use. This is an isosceles triangle. An isosceles triangle, as we all know from our elementary mathematics, is a triangle in which the 3 sides are equal and the 3 angles are equals to 60 degrees. So if this side is 2 units, this side is also 2 units, this third side is also 2 units, we'll draw a line which is called an altitude to bisect the angle at the vertex and the baseline at an angle of 90 degrees. Now, if this baseline is divided into 2, it means that this side will be 1, this side also will be 1. So, having this angle here to be 60 degrees, this one divided into 30 degrees, this angle at the base here will now be 90 degrees, which means that this triangle is a right angle triangle. And because it is a right angle triangle, we can apply the Pythagoras theorem to find this third side, which is unknown. If you apply Pythagoras theorem, this side will be root what? 3. So with this now, we can get the values of our sine 30 degrees, cosine 30 degrees. We go to the table we have below the triangle. From that table, you see that sine 0 degrees is equals to 0. Cos 0 degrees is equals to 1. Tan 0 degrees is equals to 0. Sine 30 degrees is equals to 1 over 2. Cos 30 degrees is equals to root 3 over 2. Tan 30 degrees is equals to 1 over root 3. Sine 45 degrees is 1 over root 2. Cos 45 degrees is 1 over root 2, and so on and so forth. You have the values in the table that is displayed. Now we'll come to the trig ratio of an acute angle. What is an acute angle? An acute angle is an angle that is less than what? 90 degrees. From the right angle triangle you have that is being displayed, that is triangle ABC. The longest side, which is AC, that is the hypotenuse, is R. The other side, AB, is Y. BC is X. So from Pythagoras theorem, you have S squared plus Y squared equals to R squared. That is equation 1. Now, if you divide this equation 1 by R squared, it will give you S squared divided by R squared plus Y squared divided by R squared plus, which is equals to X over R raised to power 2 plus Y all over R raised to power 2. Now, if you look at what we have up here, we see that X over R is, look at it here, X over R is cosine, Y over R is sine. So that is where we got this first trigonometrical identity, that sine squared theta plus cos squared theta equals to 1. That is that equation 2. Now, if you divide by Y, it will lead us to another trig ratio, a trig identity, that cos squared theta plus 1 is equals to cosec theta. That is the equation 3. If you also divide that equation 1 by S squared, it will lead us to 1 plus tan squared theta equals to sec squared theta. So these are the three simple trig identity that we'll be using as far as this course is concerned. Now we look at the first example here that evaluates sine theta plus tan theta, given that cos theta is equals to 12 all over 13. And theta, the angle, is an acute what? Angle. Now the given angle is cos theta. Cos theta is equals to 12 all over 13. If you square it, you have 12 squared, 144, 13 squared, 169. So it means that cos squared theta will give us 144 all over 169. Now, we know from the first identity, I'm going back again, that sine squared theta plus cos squared theta is equals to 1. That is equation 2 rather. So this equation 2 now is what we use to find the value of sine squared theta. If you make sine squared theta the subject, it means that you will have sine squared theta equals to 1 minus cos squared theta. 1 minus cos squared theta, which is 1 minus 144 divided by 169, it will give us 25 all over 169. And square root of sine squared theta will give us sine theta, and square root of 25 will give us 5. Square root of 169 will give us 13. So sine theta is equals to 5 all over 13. Again, we know that cos theta, as it was given to us in the question, is 12 all over 13. Sec theta is equals to 1 all over cos theta. So 1 all over 12 divided by 13 will give us 13 all over 12. Sec squared theta will now be 13 squared, which is 169, divided by 12 squared, which is 144. So applying the the third identity, that is equation 4. See, look at it, equation 4, 1 plus tan square theta equals to sec square theta. It will give us tan square theta to be equals to 25 all over 144. And square root of this tan square theta will give us tan theta. Square root of 25 all over 144 will give us 5 all over 12. So that is how we find the values of sin theta and cos theta as we are asked in the question above. Now we'll move straight, because we have looked at all this in the last question, last class. I just want us to have a recap. We have the trig ratios of general angles. Under this, we'll look at sine, cosine, tangent under the fourth quadrant. In the first quadrant, all the trig ratios are positive. In the second quadrant, we all know that only sine is positive. In the third quadrant, tan is positive. In the fourth quadrant, cosine, I take it again. In the first quadrant, all the trig ratios are positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive. In the fourth quadrant, cosine is what? Positive. So we have a simple way of converting from each of the quadrant to an acute angle. In the second quadrant, if you want to convert to an acute angle, we use this formula, like for sine 180 minus theta, which is equal to sin theta. For cosine, cos theta will now be equal to minus cos 180 minus theta, or cos 180 minus theta equals to minus cos theta, because cosine is negative in the second quadrant. Likewise, tan is negative in the second quadrant, and that is why we have minus tan theta to be equals to tan 180 minus theta. Now, for the third quadrant, we have we have 180 plus theta is equals to minus sin theta, because sine is negative in the third quadrant. Cos 180 plus theta will be equals to minus cos theta. Cosine is negative in the third quadrant, and tan theta is equals to tan 180 plus theta. That is how we convert from third quadrant to what? An acute angle. The last one, which is the fourth quadrant, is sin theta is equals to minus sin 270 minus theta. Cos 270 minus theta is equals to minus sin theta. Tan 270 degrees minus theta is equals to cos theta. So that is how we go about in the conversion. We have looked at all this in our last class. I'm just recapping so that for those of us that were not around, we'll be able to go flow along with us. Now, in the first example, we said express the following trig ratios in terms of the trigonometric ratios of an acute angle. First and foremost, we look at the question given to us. In Roman figure 1, we have sine 125. We need to identify which quadrant lies the given angle. In the first one here, the angle is 125. 125 lies in the second quadrant. And we also know that in the second quadrant, sine is positive. So that is why we see here that we have sine 125 degrees equals to sine 180 minus 55, which will give us sine 55 degrees. Sorry, it's supposed to be sine 125 degrees is equals to sine 180 minus 125. That will give us sine 55. Take note of that and correct it in your over there. Now, for the other one, we have cosine 225. 225 falls in the third quadrant. And we know that cosine is negative in the third quadrant. That is why we have cos 225 is equals to cos 180 plus 45 degrees, which gives us the answer as minus cos 45. And the last one, you see it there, which involves tan. So without wasting time, we'll go straight to what we need to look at this morning. We want to look at proving identity. There are no specific guidelines for proving an identity, but all that you just need to do is that you must establish the fact that the left-hand side is equal to the right-hand side. That is all that you just need to do. Now look at the first example we have there. It says show that 1 plus sine x divided by 1 plus cos x multiplied by 1 plus sec x divided by 1 plus cosec x is equal to tan x. Number 2, you have tan x plus cos x divided by sine x is equal to sec x plus cot x. Now let's come back to the first example. In the first example, you have 1 plus sine x divided by 1 plus cos x, bracket open, you have 1 plus, we know that sec x is the same thing as 1 all over cos x. We know that cosec x is the same thing as 1 all over sine x. So that is why in the second bracket, we have 1 plus 1 all over cos x plus 1 plus 1 all over sine x. Now for the numerator, the LCM is cos x. So if you find the LCM, which is cos x, you have cos x divided by 1, it will give you cos x. Cos x times 1 will give you cos x. Cos x divided by cos x, you have 1. 1 times 1, you have what? 1. So that is why I will got that 1 plus cos x. Following the same procedure, knowing fully well that the LCM of the denominator is sine s, it will lead us also to 1 plus sine s divided by sine s. So if you separate the brackets, the second bracket, we are going to have 1 plus cos x divided by cos s multiplied by sine s all over 1 plus cos s. So that 1 plus sine x here will cancel this 1 plus sine s. 1 plus cos s will cancel out 1 plus cos x. You now have sine x all over cos s. And we know that sine s all over cos s is equal to what? Tan s. So 1 plus sine s divided by 1 plus cos s multiplied by 1 plus sec s divided by 1 plus cosec s will give us what? Tan s. You follow the same procedure. All you just need to do, convert cosine, this tan to sine and cosine, find your LCM. You also arrive at sec s plus what? Tan s. So we move down to this example 2. That tan s plus sec s square, we should show that is equals to sec a plus cosec a. Tan x minus sec x square is equals to 1 minus sine s plus 1 plus sine s. The second one, sine a plus cos a multiplied by cot a plus tan a is equals to sec a plus cosec a. So these are trig identity that we just need to prove. We can be asked to prove any of them, and I believe if you study it very well yourself, you will understand it. So without wasting time, I'll come down to the second one, which is sine s plus cos x, bracket close, cot a plus tan a equals to sec sine a cot a plus sine a tan a plus cos a cot a plus cos a tan a. Now what we are doing here is that we are using this sine a to multiply cot a. We are using this sine a again to multiply tan a. We use cos a to multiply cot a. We now use cos a to multiply tan a. That is what led to what we have on the right hand side. Now for sine a cot a, we know that cot a is same thing as cos a all over sine a. For this one, we know that tan a is same thing as sine a all over cos a. For this, we know that cot a is same thing as cos a all over sine a. What you do here generally is that you convert to either sine and cosine. Now for the first one we have sine a, bracket open, cos a divided by sine a. So cos a will be remaining there because sine a will cancel sine a. This one also, we are going to have Sine A times sine A will give us sine square A divided by cos A. For this also, we have cos A times cos A, which will give us cos square A divided by sine A. And for this, sine A will be remaining because cos A will cancel out what? Cos A. So invariably, what will be left with is cos A plus sine square A divided by cos A plus cos square A divided by sine A plus sine what? A. Now, we find the LCM of cos A sine A. The LCM of cos A sine A is sine A cos A. Sine A cos A divided by 1, it will give us sine A cos A. And when you multiply it by cos A, you're going to have sine A cos square A. And you follow that order, you have what you have sine A cos square A plus sine cube A plus cos cube A plus sine square A cos A divided by sine A cos what? A. We also know from the first trig identity that we look at, sine square theta plus cos square theta is equals to 1. So cos square theta will be equals to 1 minus sine square theta. That is how we got this 1 minus sine square A. Again, for the other one, we have sine cube A. The third one, we have cos cube A. While in the last one, we have sine square A. We convert it to cosine, which is same thing as 1 minus cos square A. So we now open the bracket. That is what led to this. Now, divide all the terms in the numerator by the LCM. So that will give us sine A divided by sine A cos A, sine cube A divided by sine A cos A. So at the end of the day, you have sine A plus cos A divided by sine A divided by cos A. And this is what now resulted to the final answer that we have 1 all over cos A plus 1 all over sine A. And 1 all over cos A will give us sec A, and 1 all over sine A will give us cosec A, which means that sine A, as we are asked in the question, plus cos A multiplied by cos A plus tan A, it will give us the required answer. So we come to trig ratio of compound angle. Other trig ratios of compound angle, we have equation 1 there, that sine of two angles, angle A and angle B, sine bracket open A plus B, is same thing as sine A cos B plus cos A sine B. Now for the second one, cos A plus B is equal to sine A cos A plus cos A sine B. Now we come to the third one, which is tan A plus B. Tan, we know that tan is sine all over cosine. So since it's tan A plus B, it's going to be sine A plus B all over cos A plus B. We know from equation 1, we have sine A plus B. Equation 2, we have cos A plus B. So that is how we have sine A cos A plus sine A. That is from equation 1. While for cos A plus B, we have cos A plus cos B minus sine A sine B. So if you divide both the numerator and the denominator by cos A, cos B, it will lead to this identity for the compound angle. Tan A plus B equals to tan B plus tan A divided by 1 minus tan A tan B. Now for the difference of two angles, difference means minus, that is in equation 4. Sine angle A minus B is equal to sine A cos B minus cos A sine B. Now for the one of cosine, you see it in equation 4, which is cos A minus B equals to cos A cos B plus sine A sine B. And if you combine equation 4 and equation 5, it will give us what we have in equation 6 for tan A minus B, which is equal to tan B minus tan A all over 1 plus tan A tan B. So these are what we'll be using to solve the subsequent questions. In the example we're going to consider now, the question says, without Using table or calculator, find the value of 1 cos 15 degrees, sine 105 degrees, tan 75 degrees. We know that 15 is same thing as 45 minus 30. We're going to have cos 45 cos 30 plus sine 45 plus sine 30. And don't forget that this cos 45, cos 30, sine 45, sine 30, they are all special angles. So we have derived the value in our previous lesson. So we just substitute. Cos 45 degrees is 1 all over root 2. Cos 30 degrees is root 3 all over 2 plus sine 45 degrees is 1 all over root 2, while sine 30 degrees is 1 all over 2. So 1 times root 3 will give us root 3. Root 2 times 2 will give us 2 root 2. For the second bracket, 1 times 1 will give us 1. 2 times root 2 will give us 2 root 2. So we have a common LCM, 2 root 2, 2 root 2. So if you simplify it, you are going to have root 2 into root 3 plus 1 divided by what? 4. Again, for the second one, sine 105 degrees. 105 degrees is the same thing as 60 plus 45. So that's why we have sine 60 plus 45. So use the equation 4. It will lead you to the answer. Now for example 3, you use the equation 6. It will also lead you to this what? Answer. Without wasting time, I want us to come to trig ratios of multiple angles. Trig ratios of multiple angles. From what we have done, we know that sine A plus B will give us sine A cos B, cos A sine B. Cos A plus B will give you cos A cos B plus sine A sine B, while tan A plus B will give us tan A plus tan B, 1 minus tan A tan B. So without any loss of generality, we set B to be equals to A. If you do that, equation 1, 2, and 3 above will reduce to equation 4, 5, and 6. For the first one, it will now be sine A plus A, that is sine A plus A, which will give us sine 2A. We now have sine A cos A plus cos A sine A, which will give us 2 sine A cos B. That is what you have here. Now, cos 2A is equals to cos square A minus sine square A. And it is also equals to 2 cos square A minus 1. And it's also equals to 1 minus 2 sine square what? A. Now for cos 2A, that is when angle A and B are equal, it will give us 2 tan A. Because we now have tan A plus tan A, it will give us 2 tan A divided by 1 minus tan A. So that will give us tan square A. So that will lead to this equation what? 6. Equation 4, 5, and 6 are called multiple what? Angles. We use them in trig ratios. We can use them to show that sine cos 2A is equals to 1 minus tan square A divided by 1 plus tan square A. You follow how it is solved in the material, you arrive at the answer. We come down to the next one, the factor formula, or let's move to the more important one that I want us to discuss, because time is not on our side. We come down to inverse trigonometric function. In inverse trigonometric function, sine theta is equals to 1 over 2. It means that if we are asked to find the value of theta, it will now be arc sine 1 over 2. Arc sine 1 over 2 will give us angles of multiples of 30. And that is why you see that theta is equals to 6 minus 690, minus 570, minus 330, minus 210, 30, 150, 390, 510, and so on and so forth. Example 2 says sine theta is equals to minus 0.1, 0.515. So arc sine bracket open minus 0.515 is equals to your theta. It will give you those what? Values. Just take your time, study all this. They are all straightforward. You'll be able to get those answers as it is stated in the material. Now, in this example, we have sine theta equals to 1 over 2. I have said that. Arc sine 1 over 2 will give us 30 degrees. Cos theta is equals to 1 all over root 2. Arc cos 1 over root 2 will give us 45 degrees, and so on and so forth as we have it under that example 1. Till we get to the sixth one, which is tan theta equals to minus root 3. Arc tan minus root 3 will give us minus 60 what? Degrees. Now we'll come to the other one, trigonometric equations. In trigonometric equations, here we consider how to solve equation in which the trig ratios of the unknown angles occur. The solution of such angle can be reduced to a solution of one or more equations of the form sin theta equals to P, cos theta equals to P, or tan theta equals to what? P. The first example says, find the solution of the equation 8 cos square x plus 6 sin x minus 9 equals to 0. And the value of x ranges between 0 and 2 pi. 2 pi is equivalent to 360 degrees. Now, coming down to the solution, 8 cos square x minus 6 sin x minus 9 equals to 0. Cos square x is equals to 1 minus sin square x. So that will give us 8 into 1 minus sin square x plus 6 sin x minus 9 equals to 0. If you open the bracket and rearrange that equation, you have 8 sin square x minus 6 sin x plus 1 equals to 0. Now you will say let sin x be equals to t, so that it will lead us to the equation 8t squared minus 6t plus 1 equals to 0. This you can solve further by applying the method of solving quadratic equation. And if you factorize this equation, it will give you 4t minus 1 bracket close 2t minus 1 equals to 0. And we know that if a times b is equals to 0 from our idea in quadratic equation, it means that either a is equals to 0 or b is equals to 0. So 4t minus 1 is equals to 0, or 2t minus 1 is equals to 0. So if 4t minus 1 is equals to 0, it will give us t to be equals to 1 over 4. If 2t minus 1 is equals to 0, it will give us t to be equals to 1 over 2. But we know that t is equals to sine s. So sine s is equals to 1 over 4, or sine s is equals to 1 over 2. X will now be arc sine 1 over 4, which will give us 14.48 degrees. And x also is equals to arc sine 1 over 2, which is equals to what? 30 degrees. So that is how we solve that equation. And the second one has to do with cosine. Convert that cosine to sine. You simplify. You collect like terms, you subtract the common terms, you set your sine s to be equals to t. I'm looking at example 2 now. From there, you have 2t squared minus t equals to 0. You factorize out the common term, which is t, and you have t equals to 2t minus 1 equals to 0. So that will lead to sine x equals to 0, or sine s is equals to 1 over 2. And the arc of sine 0 will give you 0 degree. The arc of sine 1 over 2 will give you 30 what? Degrees. So that is how we solve this equation. Now we look at expression of the form a cos theta plus b sin theta. In this case, like the first one we have here, the form of r sine bracket open theta plus alpha. We know that if A cos theta plus B sin theta is equals to R sin theta plus alpha. Now, going back to the identity we have looked at, sin A plus B. In this case now, our A is theta and our B is alpha. So it means that it will give us sin theta cos alpha plus cos theta sin alpha. So if you equate the terms, you are going to have A cos theta plus B sin theta equals to R cos theta sin alpha plus R sin theta plus cos alpha. If you compare the terms, A will be equals to R sin alpha. B will be equals to R cos alpha. A square will now be equals to R square sin square alpha, and B square will now be R square cos square alpha. So A square plus B square will now give us R square plus sin square alpha plus cos square alpha. And we know that sin square alpha plus cos square alpha from the first identity we look at is equals to 1. So that is why A square plus B square will equals to what? R square. And R will be now the square root of A square plus what? B square. So that is how we all go about it, until we now eventually got to where we have tan alpha equals to A all over B, and alpha will now be equals to arc tan A all over B. Now let's come to the examples we have here. Because of time, I will only be looking at the first and second example. You have to visit the other ones at home, sit down, go through it, and I believe when you look at what I have explained to you, you'll be able to solve the third one and the fourth one. The fourth one is express the following in the form R sin theta plus alpha. We are given 3 cos theta plus sin theta. 3 cos theta plus sin theta is equals to R sin theta plus alpha. From what we have done so far there, let me just go back again. You see from here that R is equals to A square plus B, square root of A square plus what? B square. So that is how we have this. R equals to root 10. Because A is 3, the square of A, which will give us A square, is 9. B is 1. B square is also 1. 9 plus 1 will give us 10. So we have square root of what? 10. So angle alpha is equals to arc sin 3 all over root 10. And that will give us approximately 72 degrees. Alpha is equals to arc cos 1 all over root 10. It will also give us 72 degrees. And alpha is equals to arc tan 3 all over 1, it will also give us approximately 72 degrees. So the angle here, alpha, which we are looking for, is 72 degrees. So that is why we say, hence, 3 cos theta plus sin theta is equals to root 10. That is the value of R, sin theta plus 72 degrees. Now we are looking at this simple relationship here. A cos theta plus B sin theta equals to R sin theta plus alpha. So we are asked to find the numerical value of sin alpha. Now we'll come to the second one. In the second one, we have 3 cos theta minus 2 sin theta. This is equals to R sin theta plus alpha. From here, A is 3. B is minus 2. 3 square will give us 9. Minus 2 square will give us 4. 9 plus 4 will give us 13. That is why we have R to be equal to square root of 13. Now we'll come to the angle. Alpha is equal to arc sin 3 all over root 13, which is equal to 56 approximately. Alpha also is equal to arc cos minus 2 all over root 13, which is equals to 1 all over 124 degrees. 56 degrees is in first quadrant. 124 degrees is in second what? Quadrant. So we see here that arc alpha is equals to arc tan 3 all over minus 2, which will give us approximately minus 56 degree. And we need to convert it to a positive angle. You add 180 degrees to it to give us 124 degrees. So hence, 3 cos theta plus sine theta is equals to r sine theta plus 124 degrees. So follow that procedure. You also arrive at this answer that we have here. 3 cos, answer we have in the third question and the answer in the fourth question. The same procedure you use when they form r sine theta minus, now becomes sine theta minus alpha. It will also lead you to this solution we have in the question. The second one is where you have the form r cos theta plus alpha. I will advise that we'll stop the class here because I will not want us to be, having much thing to battle with. It is better we take it bit by bit. We understand all that we have learned, and by next class, we now settle down and go further. Thank you all for giving me your attention. I hope to see you by next week. So if you have any question that you need to ask, you can drop it in the chat. Let me see whether I can see some of the questions before we call it a day. I think these are their questions or what? Is there any question?